Welcome back to Understudy Jams. My name is Shubhaprasad Padhy, and today we'll be completing session 3 of Android Basics. As a reminder, the sessions are designed for people with no prior to programming experience to learn how to build basic Android apps in Kotlin. The prerequisite knowledge is that you have completed session 1 and session 2 of Android Basics with us, or on your own, you could have completed the Unit 1 from the Android Basics in Kotlin course, and that should be fine as well. If you are completely new, then worry not. I will try to make it as clear and keep it as fundamental as possible. You can also watch the session 1 and 2 available on GDSC ITER channel on YouTube for your reference later on. It's also helpful if you have an Android device, but if not, you can still use the emulator on the computer. So let's start off by recapping what we did last time. So we had learned how to write and run a program in Kotlin, how to set up Android Studio on the computer, how to start a project from a template in Android Studio, how to run an Android app on the emulator and a physical device if applicable, add text and images to a layout. We then modified attributes on a text view or image view. We then also had changed the XML code to see that how attributes are being stored in a key value pairs, and also did the same thing with the string values. Also, we learned about classes and objects with Kotlin, and then imported images in Android Studio from our file directory, and we added a button. And finally we made an application that was called the dice roller application, where you can click a button and it would roll a dice of 1 to 6, and it would show you the image of that particular dice. Now let's dive into some high level concepts that you will be learning. So to build an app, you need to understand what an activity in Android is. An activity is the part of your app that presents a window that can display the app's content on the screen. So in case of the dice roller app that we had built, there was only one activity, and it was called the main activity. And when you create an application with any predefined layout, you will be having the initial activity as called as the main activity, and you will also have a layout called main activity. And when you open up the app, the main activity launches. The layout is drawn on the screen, and the user can start interacting with the app. We modified the main activity by adding Kotlin code for what should happen when the user taps on the button in the app. So the logic is what we put inside the main activity, and in the layout is what actually is being shown to the user, and that is what we actually call the user interface. Next, we need to learn something, one of the very important topics of Android, and it is activity lifecycle. So let me just go to the next page. Yes. So activity lifecycle. As a user navigates through, out of, and back to your app, the activity instances in your app transition through different states in the lifecycle. The activity class provides a number of callbacks that allows the activity to know that a state has changed, that the system is creating, stopping, or resuming an activity, or destroying the process in which the activity resides. So within the lifecycle callback methods, you can declare how your activity behaves when the user leaves and re-enters the activity. For example, if you are building a streaming video player, you might pause the video and terminate the network connection when the user switches to another application. When the user returns, you can return to the network and allow the user to resume the video from the same spot. In other words, each callback allows you to perform a specific work that's appropriate to given change of state. Doing the right work at the right time and handling transitions properly make your app more robust and performant. For example, good implementation of the lifecycle callbacks can help ensure that your app avoids something like crashing if the user receives a phone call or switches to another app while using your app, consuming valuable system resources when the user is not actively using it, losing other users' progress if they leave your app and return to it and at a later time. Or it can also cause some crashes in, oh, sorry, yeah. Or it can also causes some crashing or losing the user's progress when the screen rotates between landscape and portrait orientation. So there are a lot of concepts, but we are only going to scratch the surface. And to navigate transitions between stages of the activity life cycles, the activity class provides a core set of 6 callbacks. And you can see the diagram as well on the right side of the screen. I hope the screen is clearly visible. And you can see the flow chart of how it is defining the callbacks. And these methods that you can see are actually the callbacks, which you can override to put the logic that you want to happen when these callbacks are actually called by the Android system whenever and wherever required. So to navigate transitions between stages of the activity life cycles, the activity class provides a core set of 6 callbacks. That is the on create, on start, on resume, on pause, on stop, and on destroy. So the system invokes each of these callbacks as an activity enters a new state. So whenever the activity goes into a different state, for example, the state after creation, or when the state of pause, when you are actually navigating to a different application, for example, or different activity, it would go to the on pause method, and the on pause method is actually called right then. So let's individually look at how these callbacks or when these callbacks actually occur. So first of all, the first thing that we have on activity lifecycle is on create method, and you must implement this callback, which fires when the system first creates the activity. So on activity creation, the activity enters the created state, and in the on create method, you perform basic application startup logic. That should happen only once for the entire life of the activity. For example, your implementation of onCreate might bind data to list, associate the activity with a view model, and instantiate some class scope variables. This method receives the parameter saved instance state, which is a bundle object containing the activity's previously saved state. So if the activity has never existed before, the value of bundle object would obviously be null. Now, after the on create method, the activity calls the on start method. It goes into the started state, and the system invokes this callback. So the on start call makes the activity visible to the user. So this is where the UI is implemented, and the user can actually visualize whatever the layout that we are wanting to print on the screen. And this method is called. So on start call makes the activity visible to the user as the app prepares for the activity to enter the foreground and become interactive. And for example, this method is where the app initializes the code that maintains the UI, and then it goes to the resume state. So when the activity enters the resume state, it comes to the foreground, and then the system invokes the on resume callback. And you can override all these callbacks to actually mention the logic of what should happen whenever this state, or whenever your application or the activity goes into that state, to make your code much more performant and reusable, and also scalable. Now, when the activity enters the resume state, it comes to the foreground, and the on resume callback is called. And this is the state in which the app interacts with the user. So the app stays in the state until something happens to take focus away from the app. Such an event might be, for instance, receiving a phone call, or whenever, if suppose you rotate your device and it goes from portrait state to landscape state, and users navigating to another activity, or maybe you are going out to some another app, and that then would take the focus away, and it would go to the on pause state. So let's come to the on pause state. So the system calls this method as the first indication that the user is leaving your activity. And although it does not always mean that the activity is being destroyed, it indicates that the activity is no longer in the foreground, though it may still be visible if user is in multi-window mode. Uh, so it is not yet completely destroyed. It is just in a pause state. And if you go back to the activity, then the focus is reshifted to that particular activity, and you can use it as you're supposed to. Now, after on pause method, there is this on stop method. So when your activity is no longer visible to the user, it has entered to the stop state. So, and the system invokes the on stop callback. This may occur, for example, when a newly launched activity covers the entire screen. The system may also call on stop when the activity has finished running, and is about to be terminated. And finally, on destroy is the final callback. Is called before the activity is destroyed. The system invokes this callback either because the activity is finished due to the user completely dismissing the activity, or due to finish being called on the activity. You can use finish is a method to actually destroy the activity, and it is very usable if you want to say remove a activity from the stack. So for example, when someone is using your application, there is some activity or some phase of that application that you to be don't want the user to come back to. For example, the splash screen, it should only come up once, and then it should be completely removed from the stack, and then you can use this method finish to actually remove it from the stack. So whenever the person goes to clicks on back or swipes to go back to the activity, it would actually not be going back to that activity because it is been completely removed from the stack. Now the system is temporarily, so whenever you call this finish method, the system is like completely being destroyed, and that is where the on destroy method is being called. And the another one would be when you are due to some configuration change, you are temporarily destroying the activity, such as device rotation or multi-window mode, and then the on destroy method might be called. And you can use these functions or methods to actually make your code much more scalable and uh, much more logical. So like what should happen when your activity is in different state, for example in the pause state, in the resume state, or being destroyed right now. And now that we have learned about activity, um, let's go to another important topic, and that is the intent. So what exactly is an intent? An intent is a messaging object you can use to request an action from another app component. Although intents facilitate communication between components in several ways, there are three fundamental use cases. First one is starting an activity. So what it means is an activity represents a single screen in an app, as we had mentioned before, and we had also developed the application called Dice Roller app. It had one activity, the main activity. But what if the app has more screens and more activity and more logic, and you want to implement another activity? You need to move on to that activity, and you can actually go to that other activity using the intent. So when I said starting an activity, that means it you can start new instance of an activity by passing an intent to start activity. So start activity is a method, and you can pass that particular intent, and you can move on to that activity. So the intent describes the activity to start and carries any necessary data. So if you want to pass some data, for example, say there is an activity for sign in, and when the user is signing in and you are getting some information about that user, and you want to pass on to the next activity where you can display it, it would be a simple application, and the passing of that data would be done through intent as well. So if you want to receive a result from the activity when it finishes, you have to call the start activity for result. So a scenario where you would be using this is, for example, say you are running camera application on your application. So let's say you have built an amazing application that can send pictures to other people, and you are actually using camera on your application to take that picture. So so when you are taking that picture, you are actually calling the camera application, and you can do that by an intent. And then you are actually getting a result, which is the image that you have captured using that camera app. So when you are getting a information or getting a return value that you want to use, you have to call the start activity for result method, and the value you will get on the on activity result method, you all written in the camel case format. And once you call the on activity result method, you can actually get the data that you are actually asking for. For example, in the camera, it would be image. If you are using some recording application, it would be the audio file, and it depends on what you are expecting. And once you get that data, you can do whatever you want to in that application. Now, another place where, or another fundamental use case would be to start a service of the internet. So a service is a component that performs operation in the background without a user interface. So with Android 5.0, and that is API level 21, and later you can start a service with job scheduler for version earlier than Android 5.0. You can start a service by using methods of the service class. So you can start a service to perform a one-time operation, such as downloading a file by passing the intent to start service. The intent describes the service to start and carries any necessary data. If the service is, say, designed with a client server interface, you can bind to the service from another component by passing an intent to bind service method. Now, another fundamental use case would be to deliver a broadcast. So a broadcast is a message that any app can receive. The system delivers various broadcasts for system events, such as when the system boots up, the device starts charging, and you can deliver a broadcast to other apps by passing an intent to send broadcast method or send ordered broadcast method. Uh, so now that was a lot of theory. And so let's take a short break. And if you guys have any question, you can put them in the chat or unmute your microphone and ask. Welcome back, everyone. Uh, so I hope my screen is visible now. I'm sharing the entire screen, and this is an application that I'll be just showing you what you can build with whatever we have learned so far. I hope my audio is clear and my screen is clearly visible. So as you can see on the emulator that we have run the code that this application is, which is basically what it is doing is it would be showing you some letters, and you can click on the letters to see some words of that particular letter, and you can change the look of it using this button. And this is something that you can build using whatever we have learned. And let's just look at some of the codes over here. So let's just look at this one first, main activity that is. So this is the basic boilerplate that we had already learned. Whenever you are going to create an application, this is something that you will be always be having. And so what it means is the name of that class is main activity, and it is inheriting the app compat activity. And then we are declaring a variable called nav controller, which is of type nav controller. And inside the on create method that we're overriding, you can see that we have the variable where we're inflating the layout and setting it as the setting the root of that particular layout as the content. And then using the fragment manager, we are actually putting the fragment that is the layout that let me show you the layout. So this is the activity main, which is completely empty. And on this, we are putting this fragment list, which is actually a recycler view. And the recycler view is consist of these, a lot of these being enumerated or being replicated over this. So whenever you have multiple elements of that recycler view, you will be having this as a particular element and being uh, enumerated in the recycler view. So this is something how it would look. And again, similarly, inside the word, it is another recycler view where we are putting multiple items, that is the word corresponding to the letter that we will be clicking on. And this is the layout that we are supposed to be printing on. And with the fragment support fragment manager, we are putting that layout over here. This is the code for it. And after that, what we're doing is in the word list manager, we are having the class word list manager, and this is having the recycler view. And so it is completely based on that. And we are overriding the methods that is on create view and on view created. So this is something that we had learned about lifecycle, and it was about activity lifecycle. And over here we're using fragments. So the lifecycle of a fragment is similar to the activity, and we can also control what the application should do or the fragment should do when it goes into a particular state using the functions or the callbacks. That is, for example, on district view, on view created, and on create view. So using override functions, we can actually provide the logic of what should happen. We are binding the view on create view, and on create, we're actually creating the particular fragments and the necessary variables that is need to be initialized. And then on view created, we are setting it, setting the, for example, the recycler view, what should be the layout manager and how the adapter should work, and that would be displayed later on the screen or the of your application. And similarly, in the letter adapter, it is actually the adapter for your recycler view. But adapter in general terms means something that changes one to a particular suit. Or for example, in this case, it is adapting the input to a particular way so that it can be presented in the recycler view. And this is how it is going to be formatted for the recycler view. So here is an example of what we want to do. We just want to print from a range of A to Z, and it is very simple. We are having the view, we are assigning the view and the button. we had learned this in the dice roller application. You can give any text value to the button and it should print that particular value, and whenever you click on it you can actually give the logic for what happens. So for example, this is something that you will have in the boilerplate, and then you can give the layout. As we have seen before, you can set the layout that we were talking about, that is the recycler view, and after that we are overriding the on bind view holder, and over there we are providing the position and the array that we are working with as an argument. So there we can choose the item that we are uh, with that we are actually going to work with. So for example, in this case, the item variable is going to be list dot get position for the position should and it should returns the value at that position, and then we are setting the uh, text of that particular button to that value, and that value we had already created before on the above method, so that should be around from A to Z, and respectively we are setting the value of the cycle view so that it should come up as this A, B, C, D, E, F, G, H. And then we are assigning the on click method, and using the navigation we can actually do multiple stuff. So I'm not going in depth about explaining how this code works, but this is just an example of what you can build easily with the concepts that we had discussed today. There are a few other concepts that we haven't touched and that has been used over here. That is the Android Jetpack navigation components and uh, navigation components, the menu, about the menu library. So how this button would actually work. And I would like you to go through the Android with Kotlin course and go through this application. It is uh, great for your learning and to build furthermore application. And that should be good for this session. Now let me actually share the screen. What will give me a second. I hope my screen is visible now. And yeah, so if you like creating more Android applications and want to continue learning more on your own, here are some resources that you can follow. First, you can keep uh, coming to study exams as we cover more topics to make you a full-fledged Android developer. And this is the last session of Android study exam. And second, you can continue learning on your own with the Android Basics in Kotlin course. Third, you can modify the apps we built together and learn by adding more features to them. You can use Google search or look at existing code samples and videos online for how to add additional features to your app. To stay connected, check out these additional resources with professional developers used to stay up to date on Android. As you get into more advanced features, you will likely need to learn more programming concepts. You can check out the Learn Kotlin by example resource for that. Android study exams will officially end on 10th of January. I hope everyone is completing the Android with Kotlin course. That is something that is necessary to receive all the perks that AS has to offer. And with that, we have come to the end of this session. I hope everyone had a good time. Keep learning and stay safe. Thank you so much for being a part of Android Study Exams. Good luck on the beginning of your Android developer journey. Thank you.